So today let's do week 9 in-term PYQs. Anyone willing to read? Lalo?
Okay. Consider the CBO model for learning word embeddings with the embedding dimension 2. The window size is 1. That is,
Read louder.
we only use the previous word as the context to predict the current word. The vocabulary is made up of the words 1, 2, 3, 4. At some point during training, the word and context matrices are given below. The first column in each matrix corresponds to the embedding for 1. The second column is for 2 and so on. W word and W context matrices are provided. The sample that has come up now during training is 2, 3. Note that 3 is to be considered as the true label here. Enter your answer. Find the probability of predicting 3 given 2 as context.
Okay. So if we remember the slides, we want probability of 3 given 2, right? So given 2 is this one, 3 is this one. So we have to do dot product. 1 minute, 1 minute. Okay, numerator dot product with 1 0 with 1 2. This is 1. And denominator dot product with all the words. So dot product with 1 0 is 1 plus 1 plus 1 plus 1. 0.25. Okay.
Okay.
So 0.25.
Using the given sample, perform one update for gradient of a gradient descent using eta is equal to 1 for the word embedding corresponding to 3. If the updated word embedding of 3 is the vector of a comma b, enter b minus a as the answer. Note that we are interested in the word embedding of 3 and not its context embedding.
Okay. So let's call this is V3 and this is UC. Okay. This is VW. What is the update rule for VW? VW is equal to VW plus eta 1 minus y hat. Y hat is this quantity. Y hat W into UC. This update rule. With this update rule, what can we 1 2 plus eta was 2, right?
Yes.
Into 0.75 to 1 0. Eta was 2 or 1?
Let's check.
Eta is 1.
What?
So this is 1.75 to this is B minus A is 0.25. Okay. 0.25.
Suppose you have a vocabulary of 5000 unique words and you want to train a CBO model with a window size of 3 and with an embedding dimension 100. How many parameters will the embedding layer have?
Okay. So we have window size 3. 3 words left side, 3 words right side. We want to predict a word. This is the hidden layer. H belongs to R what? R100, embedding dimension. And what is this dimension? 5000. We're not encoding. In CBO, we use we're not encoding here. So this is 5000. So if we concatenate these 6 words, This belongs to R 6 into 5000, and this is W context, and this is W word, and W context belongs to R 100 into
5,000.
6 into 5k, and this dimension is R 5000. Okay, and we want dimension W word. This is R 5000 into 100. So this is what embedding, word embedding. So 500,000, 5 lakh, no?
Yes.
5 zeros. This is the answer. Okay. Next.
Okay. Assume that your Vivo model outputs a probability distribution over a vocabulary of 20,000 words for a given context. If the correct target word number is 150 and the model's predicted probability for this word is 0.2, calculate the cost input belongs for this prediction.
Yeah. Actually, this is word. This is hidden. This is the input. So this is one not encoding, right? The white true.
Mm-hmm.
White true is one not encoding.
Mm.
Okay, one not encoding. So what we want to calculate? It will be minus ln 0.2.
Mm.
Correct?
Yes.
So it's 1.0.6 or 1.6. Check once in calculator. Is it correct? 1.6?
Let me write, I will write it.
Okay, I will use this only. TCS calculator. 1.6 ln.
Yes.
Oh, sorry. 0.2 ln. 1.6. So 1.6 is the answer. Next, skipgram is the reverse of SIBO.
In Skipper model, with a window size of 2 on each side, how many unique pairs of target and context words will be generated for the following sentence?
Hmm.
Predicting the future is not magic, it is artificial intelligence. Ignore the punctuations in your calculation.
Okay. Two words left and right, right?
Hmm.
Target and context.
Hmm.
For predicting P, the P future. Okay.
Hmm.
If P is the target,
Hmm.
then if the is the target, then the predict the future, the is.
Hmm.
Next, for the future predict future, the future is, future not.
Is there any numerical way to calculate this or only
No,
enumerated way?
enumerate, only
Hmm.
enumerate way for future. For next is, right? Is, the is, future is, not is, magic. Okay. For not, dictate me for not. Not future, not is, not magic, not it. Then for magic, magic is, magic not, magic it, magic is. Next for it not, it magic, it, is, it, artificial. Next for is. Now you see, already we have is, right? They ask for question is asking for unique. For is, tell is, magic, is, it, is, artificial, is, intelligence. Now is magic is already present. Are you here? Hello?
Yes, 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 yes.
So is magic is already here. So we should not count it here.
Okay.
Now can we see anywhere again similar thing? No, right?
No.
Okay. Now after is artificial intelligence. Sorry, art magic, right? Artificial magic, artificial it artificial intelligence. Then for intelligence,
Is intelligence artificial?
in intelligence is intelligence artificial.
Artificial.
So count it. One, two, three,
Three,
4, 5.
7, 8, 9, 10, 11, 12, 14, 14, 15, 16,
How many?
32.
32.
Yeah. Wait. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 15, 16, 17, 18, 19, 20. 33.
Yeah, we are getting 33. Anywhere we made twice. So number of predicting is 1. The is 1. Future is 1. Is 2, right?
Yeah. Oh, we will count artificial and magic because sizes of two now.
What?
We will not count artificial and magic.
Artificial and magic. Oh, okay. 1, 2. Oh, yeah, yeah, right. You are right.
Yes,
This
32.
is wrong actually. 32?
Yes, roughly.
Okay. Next one.
If you use hierarchical softmax with a binary tree where each leaf node represents a word in the vocabulary and the vocabulary size is 16,000, how many binary classifiers are needed?
Okay. This is actually this is leap will be the number of vocabulary, right? So it's minus 1. 16,000 minus 1. I will show you the slides. See the red nodes here, leaf nodes
Yes.
in this slide. Okay, those are vocabulary. Okay, for each vocabulary, one word will be there, and number of internal roads will be minus 1.
Yes, okay, yes. Okay.
Okay, I will explain with a simple example here. This is level 0, level 1, level 2, right?
Yes.
So number of nodes present here will be 2 to the power of 0, 2 to the power of 1,
Mhm.
2 to the power of
Uh,
2. Now, if similarly, if we say 2 to the power of 3 also, for some explanation purpose. Now, if we add these things, 2 to the power of 0 plus 2 to the power of 1 plus 2 to the power of 2, this is 2 to the power of 3 minus
3
1,
minus 1.
2 minus 1.
1.
So we are getting 1 less than the last node.
Yes.
Okay, that's why answer is 15999.
5999.
Everyone understood this?
Yes.
Okay, next skip gram. Opposite of SIBO.
Okay. In a skip-gram model with a vocabulary size v equals to 100 and reading dimension d equals to 10 and the window size of 3 on each side, using a negative sampling with 5 negative samples per positive samples, what is the total number of parameters in the model?
Okay. So in skip gram, we have only one word here, and window size 3 means 1, 2, 3, 4, 5, 6. And this is hidden layer belongs to R. Embedding size is 10. Okay.
Okay.
Now we want to calculate what is the total number of parameters in the model. Okay. Vocabulary size is 100. So this is 100. This belongs to R100. This is the total number of parameters in the model. So let's see image of SIBO. Sorry, skip gram. This is the skip gram, right?
Yes.
Uh, okay, this is the image of skip gram. Okay, 110 for the input, it's 110 encoding, right? It belongs to R
We
100.
yes.
Okay, so this is W word. W word belongs to R 10 cross 100, right?
Yes.
10 cross 100 is 1000 here,
Thousand.
and here we have to consider one, and this these are negative, right? 5 negative samples.
Yes. Okay.
So W of context belongs to R 100 cross 10. So this is again 1000, 1000, 2000.
Okay.
So why we are not multiplying in 1000 into 6 is these are negative, same way it will be there.
Yes.
Okay, if you see the slide here, see this is hidden. These 4 words same as identify one word at a time. Understood, no? See,
Yeah.
it's
Can you
hidden.
please repeat this? Hide what is?
See, in the previous slide, we had 4 words, right?
Yes.
So calculating 4 words same as calculating individual 4 times.
Okay.
I'd other 3. We will in the simple case there is only one context word. So one context word means same equation, right?
Okay.
And it's you do same word 4 times, like this.
Yes. Got it.
So what is the formula of PMI? Probability of PI, Pj by probability of Pi into
uh,
probability of.
probability of W.
If it is probability, we take this one. If it is not probability, then count which occurred I and j together into n by count of
Count of
Wi
WI dot
into
count
count
of
of Wj.
J.
So what is this answer? 0.02 by 2,
0.2 multiplied 0.3.
0.3. This 2, 2. So 2 by 2 into 3, right?
1
One
by
third. And we have to do ln 2, right? Ln 2.
yes, log 2.
Log 2. So log 2, 1. So
Right.
this is 3, 2. 3 ln divided by 2 ln 1.58.
Yes, 1.58.
But we are getting different answer. If we take log 10, otherwise let's see the slide. Yeah, it's log.
Okay. Okay, so log 10 is giving the answer anyway.
Uh, ln
3.
1/3, right?
Yeah, 1/3.
0.33. Okay, this is also not correct. 0.33333. 0.477. Okay, log base 10. So main takeaways, we have to take base 10.
Okay.
And
Sorry.
we got minus, right? So PPMI will retain only if it is positive.
0.
Otherwise, it make it 0.
Yes. 0.
Okay. Main takeaways in PPMI, we should take log. Okay, base
Okay.
10.
So it don't matter if we take count or this probability. We have to take log
No,
10 only.
yeah, wherever. Yeah, always log 10 only.
Okay.
You see, in count also log 10 only.
Okay.
Next.
Given a matrix A with dimension P and Q, which of the following statement is not true regarding the rank K approximation of A obtained through singular value decomposition? Option A, the rank K approximation matrix will have dimension P cross Q. The matrix UK in the rank K approximation has dimension P cross K. The matrix of sigma K in the rank K approximation has dimensions K cross K, and the rank K approximation matrix will have dimension K cross.
So this is the formula, right? For
Yes.
K times approximation.
Yes.
Any explanation needed in this question? This each matrix will be P cross Q, and the summation of this is a matrix, right? Outer product. Okay. So
Okay.
summation of P cross Q. So total will be P cross Q. All okay. Matrix will have dimension P cross Q, and UK is this one. That will be P cross K. Summation will be K cross K. And the rank K approximation will have dimension. It's not K cross K. It will P cross Q. And they ask for not.
Okay, yes, not true. Yes. Got it. Suppose you have a vocabulary of 10,000 unique words and you want to train a CPOW model with a window size of 2 on each side and with an embedding dimension of 300, how many parameters will be embedding layer?
Okay. Window size 2. This hidden layer belongs to 300.
R300,
And this is one not encoding. This belongs to R
10,000.
10K. Okay.
Yes,
And this belongs to R 10K.
10K.
And while training, we append it, right? Concatenate. So this belongs to R 60K. No, 40K, right?
Yes,
So here W context will be there. This belongs to R 300 into 40K.
40K.
300 into 40K. And this W word, this belongs to R 10K into 300.
300K. Oh,
So
sorry,
3
300.
million. 3 million, right?
Yes.
3 zeros, 3 zeros, 6 zeros, 3 million. Next.
Assume that your CPOW model output has a probability distribution over the vocabulary of 20,000 words for a given context. If the target, if the correct target word is word number 150 and the model's prediction probability of for this word is 0.02, calculate the cross entropy loss for this prediction.
This is minus ln 0.02. 0.02 ln 3.91.
Yes.
3.91. Okay. Scriptgram.
In the skipgram model with the window size of 2 on each side, how many unique pairs of target and context words will be generated for the following sentence? The idea is to die young as late as possible.
Okay. First, any. Okay. There are repetition of as. We have to take care of that. Okay.
Okay.
Now, tar- window size 2. So the idea, the is.
The,
Correct. Next,
yes.
idea is, idea, the idea
Idea to
2. Then for is
the,
also it is 4 only, right? We can write 4.
yes.
For 2 also 4.
For die for
4. For
young
young
for
4. For this first is 4.
for
This is also 4. And for the second, how many? 1, 2, 3.
3.
This is already there. It's 2.
Yes. As
And
late is also there, no?
yeah, you are right. So it's
1.
only 1. Correct, no?
Yes.
Okay,
And
possible?
possible 2.
Possible. Count.
32.
We're getting 32.
Yes.
Window size of 2 on each side. One, two.
Like, will we include like as and as pair? Because we have unique words, no? As pair will be included.
Yeah, yeah. Yes, yes. This is allowed, but another yes is not allowed because once we count this one. How much are we getting?
32.
Okay. Do we exclude this? What do you think?
Yeah, that's why we are, that's why we're getting the answer.
I don't know this actually. Anyone knows? Okay, we can ask this with us, sir.
No, you already excluded it. Right?
Okay, we can. Shall we ask this? Anyone take the screenshot and ask ChatGPT? Can you do that?
Yes, yes, I'm doing that.
What's the output?
It says 31. Not giving the correct explanation. It's counting itself as 30.
Okay, then we can discuss this later. Okay, next question.
In the skip-gram model with a vocabulary of 15,000 words, if you choose a negative sampling rate of 10 negative samples for each positive sample, how many total samples will be generated for a sentence with 8 unique words and the window size of 3 on each side?
Okay, 8 unique words. W1, W2, W3, W4, W5, 6, 7, W8.
Okay, we got the answer, I guess, no? For the previous question.
Okay.
Yeah, for late, we are counting late as and late as twice. For the late.
Okay, late. Yeah, yeah, yeah. Correct. It should be 3.
Yes.
Nice. Thanks. Okay. Maybe if we had enumerated it, we would have made it correct, right?
Yes, yes, yes.
Okay. Okay, next question. This we have 10 negative samplings for each positive sample. Okay. First count how many positive samples are there. This is like this. I will show you. Okay. For size of D dash, wrong pair, k times of the d, right?
Okay.
This will have how many pairs? 1, 2, 3. This will have 3. This will have 4.
4,
This will have 3 plus 2, 5.
5,
This will have 6.
6,
This will have 6.
6, 5, 4, 3.
3. Positive samples, how many? 10 plus 8 plus 18, 36. Correct?
Positive sample is just the total of this.
Yeah, positive sample is this one. And for each sample, we multiply with 10. 10 negative. So 360 is the answer, right?
Okay.
396 are we getting here? Check this with the ChatGPT.
It says like total samples multiplied not by multiply 10 but multiply by 11 because 1 positive and 10 negative. 36 into 11.
Oh, 36 into 11.
Yes. For each positive, we generate 10 negative. So total per positive is 1 itself plus 10 negatives equals to 11 samples.
Okay, okay. The correct and wrong one, wrong two, up to wrong
10.
10.
So
This
total
will
11.
C 36,
36.
wrong one,
Wrong.
wrong two,
Wrong.
so wrong 10. Okay, nice. Thanks. Okay, shall we go to next question?
Yes.
Maybe this is shown here. I missed it actually. See, like this. For each one, we have to make a tuple by picking one from here and k from here, d prime.
How
Can
can you
you
please explain that? How?
for this is d, okay, correctly sampled.
Okay.
D prime is incorrectly sampled. When we make pairs, we take this sat on and all these things. So we are making a tuple. Like I will explain here. So we are making like this. Sat on and sat oxygen, sat magic, like this.
Okay.
This is correct one. This is wrong one. Okay.
Okay. Okay. Okay. So while counting, we need to multiply this to first total them and then multiply it
What?
This
in the previous one.
Huh?
So what is the final formula? Like D into
D into k plus 1.
like correct one is the set on, set
Okay.
A, and set
D
J.
for 1, we have d dash plus 1.
Okay.
this one 360 plus 36 for a complete. Complete.
Yeah, 360 into 11.
No, the one we have calculated is 36 into 10 is 360. So
So
the
you are saying
total.
you place 3636 here,
Uh,
but actually the thing is, even though it's numerically same, but we should do 36 into 11, because see
mm,
this size is 11
mm,
and this what rows are 11. Rows
right.
are 36.
36 hours.
Okay.
This is having more meaningful than plus 36 here. 36,
Mm.
even though both are same. Shall we go to the next question?
Yes.
Yeah.
Suppose we use the CPOW model shown below to find the distributed vector representation for all the words in the vocabulary. The size of the vocabulary is 150 and all the words in the vocabulary are one hot encoded as column vector and fed as input to the network. The output layer uses softmax to produce the probability score for each word given the context here. W word and W context are weight matrices. How many number of parameters are there in the network excluding pairs? Bias.
Okay, it's 150 into 5, 750.
Yes.
Oh no, where have we gone wrong? Okay, okay. They didn't ask for only embedding layer. This is embedding layer, right? This embedding layer, and it's one not encoding. This is one not encoding. This also belongs to R150, right?
Yes. Okay.
So this
Okay.
is 750.
And this is
This is again
750.
750, 1500.
1500.
Yeah, after seeing answer only, I made the solution. Okay,
Yes.
in the network, in excluding bias.
Okay.
Okay, if you had bias, what will become? What will change? This is 5 into 150
Yes.
plus 5, right? Bias will be 5. This is a feed forward neural network. Here are 150 into 5, so plus 150. Everyone convinced this one? If it is including bias. Got it now?
Why we included 150 here?
150, you think uh, R 150 into 5, this is W, right?
Yes.
And we multiply with HK. This is R 5 into 1
Yes.
or 1 into 5. 5 into 1, okay?
Yes. Yes.
Now we get what vector?
150
Let's
into
call it the result. Um, okay, let's call it R. So
A.
okay, let's call it Z. This will be 150
150
cross 1,
into
right?
1.
So adding
Yes.
bias, we should also will have 150 bias.
Oh.
Made sense?
Yes.
Okay, including bias is this one. Okay, shall we go to next question? Any doubt here?
So basically, we include the upper thing, na? Like R150, we included 150, and for
Hmm. So
R.
you can think like this also. So with the notations. So this is input layer. This is hidden layer. This is output layer. Let's say how many? These are 150 nodes. This is 5 nodes. This is 150 nodes. This is W1, B1. Here W2, B2. What is the dimension of W1?
1.
5 into 150.
Yes.
And dimension of B1 is 5. We write what is this? Let's say H0. This is H1. Before H1 we have A1 and this is A2, H2, right? How to write A1? A1 is equal to W1 H0 plus B1, right? Feed forward neural network, right? Are you able to follow this?
Yes, yes.
So similarly, and H1 is the activation. Okay. Similarly for A2, W2 H1 plus D2. What is the dimension of W2? 150
8
into
to 5.
5. D2 is 150. If it is including the base. Okay.
Yes. The word representation for the second word in the vocabulary corresponds to second column of word context, second row of word context, second column of word, and second row of word. Second
Okay.
column.
Word representation. A second column of the W context, right? What's the answer? Okay, second column of the W context. Why this is so? Because it's one not encoding. So when we multiply with 1, this is the reason. Okay. Ith column of W context is one to one corresponding with the word. And why not second column of the word? Okay, that I will answer here. Okay, probability depends on the word matrix. Okay, W word, and embedding depends on the W context.
Okay.
This one we saw solved in the first question. Remember this one?
Yes, yes, yes. Based on the above data, answer the given sub-questions. Construct a vocabulary V from the following text corpus. How much wood could a woodchuck chuck? If a woodchuck could chuck wood, as much wood as a woodchuck could chuck.
As a tongue twister.
Yeah.
Size of the vocabulary. Okay, let's start counting it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right?
Yes. No, no, no. Not 10. It is
Where is as before?
third line, first word.
Oh, yeah. Food is also over.
Yes.
So 9. 9 is correct.
Yes.
Read.
Suppose we consider the three words wood, woodchuck, much. Assume we use one hot encoded vector representation for all these words. The statement that the cosine similarity between the pair wood and woodchuck is greater than the pair wood much is true or false.
Okay, for one not encoding, what is the dot product will come? 0, right?
Yes.
0.
So how can we say greater? It's equal. Equal
In
to
one of encoding, we can't find any similarity between the words, right?
correct. And Euclidean distance will be root 2. This is Euclidean distance. This is the drawback. That's why we developed SIBO, skipgram,
Mm,
SVD,
SVT.
like this. Next.
Consider the sentence. Inside the quote, I may be wrong and you may be right, and by an effort, we may get nearer to the truth. Based on the above data, answer the given sub question. What is the size of vocabulary V?
Okay. 1,
2,
2, 3, 4, 5, 6,
answer. 7,
7,
answer. 8,
8,
9,
9,
10,
10,
11,
11,
answer. 12,
12,
13,
13,
14,
okay, 14,
15, 16.
15, 16, 16.
Suppose all the words in the vocabulary are represented using one hot encoded vector of size V. Then compute the ordered pairwise, that is Cartesian product of V cross V, cosine similarity between the word representation and enter their sum.
Is it similar to the sub-question of this one? Okay,
Yes.
mostly yes. What is the question understanding have you got? Cosine similar to one not encoding it 0, right? What is the answer? 16. Oh, okay. How 16? Have you got any idea? Anyone? Think it's a little easy only. Cosine similarity between I and I is 1, no?
Okay, yes.
I and May is 0. So all diagonal entry will be 1, off diagonal will be zeros.
Yes, yes, yes. Got
Okay,
it.
that is the reason. That's why 16. They said all pairs. Pair will include itself, right?
Yes, yes. Consider a model shown below uh, that that learns the distributed vector representation of the words by learning to predict the target word VW given the context word UC. Here VW and UC are the vector representation of target word at index W of the output vocabulary and context word at index C of the input vocabulary respectively. In the diagram, we denote the size of the vocabulary, W context and W word are learnable parameters. The vector representation of all the connected words are arranged as columns of W context, and the vector representation for all target words are arranged as row vectors in W word. The parameters are initialized randomly. The input X is one hot representation of a word in the input vocabulary. Assume that the size of both input and output vocabulary are equal.
Okay. What is the question?
Suppose the input is X, one hot representation of the context word and corresponding label is y, one hot representation of target word. The quantities h, uc and y cap are computed as follows: h equals to uc equals to w context x, z equals to w word uc, y cap equals to softmax z. Choose the expression that the model has to minimize using the cross entropy loss. Assume natural law.
Hmm. Have you got any idea? So let's see slide. So this is update rule. If this is the update rule, what is the loss? This is the loss. Minus and plus. Minus and plus. Okay, this is directly from the slide. This is the loss. I will put this in the for reference. Right?
Okay.
Okay. We used this update rule in the beginning, remember?
Yes, yes, that one. Theta is provided and we calculated it.
Okay. So these things can be tested. So we should, while revising, we should focus these things.
Yes.
Okay. Still, how many questions? Last question.
Suppose we compute the gradients and update the representations with eta is equal to 1. Choose the correct statements. Suppose the model predicts target word VW with a probability score of 1, then no elements in VW will get modified after one iteration.
This is the update rule for W word column. If it is 1, then there is no update. V remains
Oh,
VW. Column remains as it is.
okay.
Then
Suppose the model predicts target word VW with a probability score of 1, then no elements in VW will get modified after one iteration. A parameter update.
so what's the difference between these two?
Same, same.
Okay, here they are talking about the particular column. Here they are talking about different column. Different column anyway doesn't depend on y equal to 1 or y equal to 0.
Hmm.
No update will happen in different
Hmm.
columns. The column which participated in the forward propagation only will get updated in the backward propagation.
Okay.
This is different column. W prime not equal to W. Okay,
Okay.
that is true. And
Suppose
this
the
one.
model predicts target word VM with a probability score of 0.5, then elements of VW will be modified as its direct formula.
Their formula eta equal to 1. They said in the previous top question. Eta equal to 1. Okay.
Suppose the model predicts target word VW with a probability score of 0.5, then the elements of VW will be modified as VW dash is equal to VW dash plus Y hat V dash UT transpose, UC transpose.
This
So the
I
formula
thought
itself.
it won't update, but here it's saying update will get updated. How to know this one?
No, we have the Y hat score. If they provided the Y hat performance, Y hat.
See in the slide, uh, we think about only W, where VW participated in forward propagation. What about other W? What happens to representation of two words? Okay, this is explanation. Okay, from this option only we have to learn that other columns of W word will also get updated with this formula. Okay, learn from here only then.
Okay.
V W prime. How this 0.5 is affecting? Okay, like this. V W prime minus y hat W prime.
Should be 0.5.
No, this is W prime is here, but this is W. This is Kibram or what? Sibo. Sibo, no. This is Sibo.
Yes.
Again, Sibo. One will be there. Okay, I understood a little bit. I can explain you. Uh, okay. Let's say the same question which we had 1, 2, 3, 4. Let's say this is W word, and here hidden layer is there. Here W context is there. So we calculated probability of 3 given 2, right? So we given this 2 calculated, but this is as a numerator and rest all as a denominator, right? But now, while backward propagation, only this will get updated, right?
Yes.
So here, this is again softmax. Okay. So while coming back, we use this y hat w, which this w, this y hat, right? Y hat
Yes.
w. So this will be used to update this thing. To update these things, I will change the color. To update these things, we have to use these probabilities. This is y hat w prime,
Okay. W prime.
and this is v w prime. And the update rule, after learning from this option only, the update rule is v w prime is equal to v w prime minus y hat w prime uc transpose. UC transpose or transpose to match the dimension. That's it. UC will remain as it is. UC only. Okay, this thing I learned from here only. It was not mentioned in the slide.
Even after seeing the last option, I thought that the last should be right.
So one among these two will be definitely right. Okay. In the exam, I would have left these two also. Why to take risk when we have 3 options already? Okay, now shall we go to next question?
Yeah. Consider the following two sentences. A man was sitting at the bank of the river and gazing at stars in the sky. A man went to the bank to check his current balance. Suppose we get the word representation for the word bank in both the sentences using CBOW model, which was trained as shown in the image below. The model was trained by building a vocabulary that contains the unique words in the sentences. Then the statement that the word representation for the word bank will be different will be different based on its context is. So we are using CBOW. Word representation for both the sentences.
The bank will be different based on the context. Do you think it will be different, or means they are talking about this matrix? Sorry, this vector.
This will be, the input will be same.
The input will be same.
See, bank of the river and when to the bank is different to check current balance.
Yeah, it is different, but
Hmm.
SIBO model doesn't have self attention,
Yes,
so
at least will.
it won't be different.
Yes, at least in the input layer it will won't be different.
Okay, so it will
Yes.
be same. This is
Hmm.
the drawback for pre-trained embedding.
Hmm.
So to handle this only, self attention came.
Yes.
Okay, next question.
Consider a skipgram model shown below. Each word in the vocabulary is represented as one not vector of size 100 cross 1. The embedding dimension h is 5 cross 1. Enter the number of parameters in the, so 5 cross 100 plus
You forget this three first.
again 100 cross 5 into 4.
Uh, what is the vocabulary size? Okay, vocabulary size is 100 only, right?
Hmm.
So this is
100 cross 5,
500, right?
500 into 4.
500 into 4.
So 2000.
2000 plus 500. 2500?
Yes.
Let's start. Okay, 2500. But why we haven't kept this W context same for all here, 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 here? Because this is not that different wrong word pair, right?
Hmm. The
Because we,
Hutch embedding will be different.
hmm. No, we are talking about W context. For this one, W context 1, W context 2, W context 3, W context 4. That's why we made 4 into 4.
Hmm.
But in the previous question, where skipgram with negative sampling, we didn't do that. Remember, we didn't multiply into 4.
Oh,
Yeah, forgot it somewhere above.
I left in between, I think, at the time.
Okay,
Is
skipgram.
Cebu.
Somewhere we didn't multiply in the numerator. See this
Here on
question. I
questions.
got it. Read this question again.
In skipgram model, with a vocabulary size v is equal to 100 and embedding dimension d is equal to 10 and a window size of 3 on each side using negative sampling with 5 negative samples per positive sample, what is the total number of parameters in the model? So the input will be 100 cross 1.
Here negative sampling are there, no? So we keep W context same for all. That's why we don't multiply into 6 here.
Okay.
But at the end, we multiplied it, right? This is the
Mm-hmm.
what difference I'm trying to convey.
Okay.
In negative sampling, don't multiply.
Hmm. Okay. So this is the
You
last
remember
question.
this also, right? This minus will
Yeah.
come.
Hmm.
These probabilities.
Okay. A text corpus contained the following two sentences. In science, if you know what you are doing, you should not be doing it. In engineering, if you do not know what you are doing, you should not be doing it. Based on the above data, answer the given sub questions. Uh,
Vocabulary.
Vocabulary size
Okay, count.
1,
Okay,
2,
1, 2, 3,
3,
4, 5,
5,
6,
cancel 7,
7, 8,
cancel. 9,
9,
10,
10,
11,
11,
cancel. 12, cancel. 13, cancel. Cancel. Cancel.
where is do?
Do, okay, sorry. 14, not cancel.
10 is
Yes,
there,
yeah,
but 10,
yeah. 10 not is
5,
15.
5,
Okay, yeah, 5 is there. What? Cancel. Cancel. Cancel.
no, 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 cancel.
Cancel. Yeah. Cancel. 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 Cancel.
It,
It is. Wait. Yeah, it is 12.
12, yeah, so 14,
So
14 is correct.
suppose we build a co-occurrence matrix of size m cross n, where each row corresponds to a word in the vocabulary and the columns corresponds to the context of the word. Which of the following would be a valid size of the co-occurrence matrix? 14 cross 14.
The first is what? V, right? If we
Hmm.
add co-occurrence matrix, that will be 14 cross 14.
Hmm.
To avoid the length, we can delete a row
Stopwords.
stopwards, but we should not delete a column. Why? Actually, in the slide, it was mistakenly shown differently. Wait, I will show you.
In, in lectures, we mostly stuck with the square matrix, right? M cross
Yeah,
n.
but square matrix, no, see, I will show you. Wait. So far,
Hmm.
square matrix.
Hmm.
See,
Oh, okay.
suddenly we removed per from both.
Hmm.
So this
But
is
it
capping. Okay, this is capping. I will show you removing it. Okay, fine. So we removed per from both
hmm.
row and column, right?
Hmm.
Ideally, we should not remove from the row. We should not remove
Oh.
this. If
Hmm.
we remove that while training, there will be no embedding
Hmm.
per
Hmm.
right.
The vocabulary size then will vary.
Yeah, if you remove from both,
Hmm.
then here in SVD, it won't be m cross n, right? It will be m into m only.
Hmm.
So that is the reason we should not remove from the row. We can remove from the column.
Okay.
So row should
So
be 14 only.
anything value 14 cross
14,
below 14 is fine.
yeah, 14 cross below 14.
Hmm.
So that's it.
Okay.
Yeah,
Okay,
finish.
that's
Yeah, I will stop recording.